So today we'll start organic chemistry. So the first thing, the definitions, just a quick revision of what you took in AS. Hydrocarbon, what are hydrocarbons? Compound which contain carbon and hydrogen only, such as alkane, alkene, and alkynes. Then what are saturated hydrocarbons? Saturated hydrocarbon means the compounds throughout the structure, they have a carbon-carbon single bond. We call them as saturated hydrocarbons. And compounds within the structure, if there is a double bond, presence of a double bond, we call them as unsaturated hydrocarbon. The molecular formula, the formula which represent actual number of atoms. Like example, if I write C3 NH8, so it shows that there are actually 3 carbon atoms and 8 hydrogen atoms. Same way, if I write C4 H10, so it shows that this compound contains 4 carbon atoms and 10 hydrogen. The empirical formula, what is the empirical formula? The formula which represents the simplest ratio. In this C3 and H8, because 3 and 8 are already in a simplest ratio, so which we cannot further simplify. So some of the compound have the same molecular and empirical formula. But if it was C4 and H10, when we take a simplest ratio between 4 and 10, it is 2:5. So C2H5. Journal formula, like the formula which shows or which can be used to find any member of the series, that refers to a journal formula. As we already know or discussed, like alkanes, the journal formula is CnH2n plus 2. For alkenes, it is CnH2n. So different series we have. So for alkene, we have CnH2n. For alcohols, it is CnH2n plus 1 OH. What is a displayed formula? The formula which shows the complete structure of the molecule, that's known as a displayed formula, like in which we represent all of the covalent bonds present in the molecule. So example, if we have say we have C4, example we have C4 and H10, which is butane. So when we represent all of the bonds between the carbon and between carbon and hydrogen, all the covalent bonds, what we call this formula, we call this formula as a displayed formula. And what is structural formula? The structural formula, the formula which shows a minimal detail. If I say draw the structural formula, so this is one group, this is another. So when I represent them and show a minimal detail, like instead of carbon with 3 hydrogens showing all the bond, I wrote CH3, then it's CH2, then another CH2 is there, and then CH3. So what we call that as a structural formula. So in displayed, we represent all of the bonds, where structural we shows the minimal detail for the structure. Then skeletal formula only represent the carbon structure and the functional group. The formula which represent a carbon structure and functional group is known as a skeletal formula. So example, here we have 4 carbons, so we use zigzag line, 1, 2, 3, 4. So 4 carbon are there. We don't have to represent hydrogen here, and there is no other functional group present. That's why we represent only by the lines to show that this is the first carbon, second carbon, third carbon, and fourth carbon. Now, naming these compounds, this is just a revision what you took in AS, like how to name the compound. So if we are naming a branched hydrocarbons, so what is the rule? The rule is select the longest carbon chain. Like in this example, this structure is given, and say you don't know the name of this structure. You want to find or you want to name this structure. So how you can name this structure? You have to select the carbon chain. Like first mark the end. This is one end. You can mention A, B, C, and D. So there are four ends. So I have to count from one end to another, and I will select that carbon chain which is having a maximum number of the carbon. So if I count from A to B, 1, 2, 3, 4, 5, 6. So 6 carbon are there. If I count from A to C, 1, 2, 3, 4, 5 are there. And if I count from A to D, 1, 2, 3, 4 are there. But if I count from B to C, 1, 2, 3, 4 only. If I count from B to D, 1, 2, 3, 4, 5, 6, 7. B to D or D to B, it's the same thing, so 7. And if I count from C to D, 1, 2, 3, 4, 5, 6. So where I have maximum if I count from B to D. So whenever I select the longest chain, it is from, in this example, it is from B to D, means from end B to end D, or from D to B. After selecting the longest chain, we have to number the carbon atoms. So when we number the carbon atom, the numbering should start from nearest branch. So if I number from here, from B, if I start my numbering 1, 2, 3. So first branch is coming at 3. If I number from D, 1, 2, and 3. So the first branch is coming at 3. So both cases, the branch is coming at 3. Even I start numbering from B, or I start numbering from D, and B or ND. So it does not make difference to the name. That's why I can follow any numbering. I'll get the same answer. So how we name this? First, we mention the position of the branch. So which position we have a branch? We have a branch at the second position, third position. The first branch is at third position, and there's another branch also. What is coming outside the chain is considered as a branch, as a fifth position. So we have third position there's a branch, and fifth position there's also a branch. How many carbon atoms in each branch? One carbon. Whenever one carbon is there, the prefix which we use, that is meth. So we'll say meth. And because it's a branch alkyl group, so YL will be there. But how many identical branches are there? Two identical branches. That's why we are using a term di. Di means two. So 3, 5 dimethyl, and 1, 2, 3, 4, 5, 6, 7. So for 7, it is hept, and they have a single bond. So it should be in. So it should be 3, 5 dimethyl heptane. Is it clear, this example? Then this is a table which is showing all the functional groups which you will go through in this A2 chemistry. Some of them already you studied in AS, like alkene, carbon-carbon double bond is there. Then name should end at ENE. Alcohols, it should have OH, the name should have OL. Halogen alkane, chlorine, bromine, iodine. So chloro, bromo, iodo should be there in the name. Aldehyde, when C double bonded with O and H is there, we call aldehyde. And only if C double bonded with O is there, then we call that as ketone. Aldehyde means the carbon which is having a C double bonded with O is always at the end. Where in ketone, the carbon will be between the other carbons. Carboxylic acid, C double bonded with O and OH. Nitrile group, carbon triple bonded with nitrogen. And if it is suffix, like if we are using it as a suffix, then nitrile. If we are using as a prefix, like we use it the first name, then it will be cyano. Amines, what is the meaning of amine? Amine means NH2. When NH2 group is there, we call amine. So if it is suffix, amine is there, and if prefix is there, I will mention the names as well, how you got the name. Ester, ester means C double bonded with O and O. It's called ester. The name should be O8. Acyl chloride, when C double bonded with O and Cl is there, that's called acyl chloride. And amide, when C double bonded with O bonded with NH2, it's called amide. And the name should also be amide. So why the first compound is ethene? Eth because there are two carbon atoms, and ene they have a double bond. Then 1, 2, 3, so that's why it is prop. They have a single bond throughout the chain, that's why an. And the position of OH functional group you should always position. So if I count 1, 2, 3, the OH is with the third carbon. But if I count from right hand side, 1, 2, 3, OH with the first carbon. That's why it is propane 1-ol, the nearest branch. Then halogen alkane, like example, chlorine, bromine, or iodine. So 1, 2, and 3. If we name as a prefix, so and it is used as a prefix. So first position we have a chlorine, so we call 1-chloro. And 3 carbon atoms are there. Because of 3 carbon atoms, it is prop. They have a single bond, ane. Then aldehydes, normally we use as a suffix. So in this one, you can see 2 carbon atoms. That's why it's eth. Between the carbon atom, there's a single bond, so it is N. And due to this functional group, C double bonded with O and H, it is aldehyde, so it is al. So it's ethanol. When C double bonded with O is there, 3 carbon atoms, that's why it is prop. They have a single bond, that's why it is N. And due to this functional group, it is 1 or on, so it is propanone. You can, when it is symmetrical ketone, you don't number the carbon which is having, like it is symmetrical. Symmetrical, you can see equal number of carbon are surrounding the functional group. But some of the ketones are not symmetrical. So in that case, when you name them, you position the or mention the position. Say if it was CH3, CH2, C double bonded with O, and CH3. Now in this case, it is not a symmetrical ketone. Why? Because one side of a functional group, there are 2 carbon atoms, and the other side, there is 1. In that case, you have to name the carbon atoms 1, 2, 3, 4. If I number from right hand side, the second will have a functional group. If I number from left hand side, 1, 2, 3, 4, the functional group is at the third. So we should always follow a numbering where it is the functional group or the branch is closer. That's why we are numbering from right hand side in this example. So the functional group with the second carbon, so we'll say but because there are 4 carbon, and because they have a single bond between the carbon atoms, and the ketone is with the second carbon, so it is 2 on. So it is butane, 2 on. So 2 on is representing the position of C double bonded with O. Then carboxylic, when C double bonded with O and OH is there, that's called carboxylic. 2 carbon atoms are there, that's why it is eth. They have a single bond between them, it's N. And due to this C double bonded with O and OH, it is oic acid. Nitrile group, when C triple bonded with N is there, but when we name them, like we should include this carbon because this is a carbon, so we should include this carbon when we are counting. So it is not eth, it is prop. Why prop? 1, 2 and 3. So prop because 3 carbon, and between the carbon atoms there is a single bond. There is a triple bond between carbon and nitrogen, but within the between the 2 carbon atoms within the structure there is a single bond throughout. So it is prop N. And nitrile group, why nitrile group is there? Because of this functional group C triple bonded with N, we call that as nitrile. Amine means NH2. When NH2 group is there, we call them as amine. So 1, 2, 3 carbon. So we say prop 1. 1 is a position of amine, and the amine group is with the first carbon. Ester, the part which is connected with oxygen is a branch, and the part which is connected to C double bonded with O directly, that carbon chain is known as the main chain. So in this one, C double bonded with O, so the part which is attached with oxygen is a branch directly, and then the other part is considered as a chain. So 1 carbon in the branch, that's why it is meth, and because it's a branch, so il, methyl. And 2 carbon in the chain, that's why it is eth. They have a single bond between them, N, and due to C double bonded with O and O, it is OH. So it's methyl ethanoate. Acyl chloride, C double bonded in detail, all are there. This is just introduction of the topic. So C double bonded with O and Cl. Example, we have CH3, C double bonded with O and Cl. So we have 2 carbon, so that's why we call eth. They have a single bond between them, N. And oil chloride is a suffix which we use. So you can see oil chloride. So it becomes ethanyl chloride. And the last one, when C double bonded with O and NH2, it's called amide. So 2 carbon atoms, that's why it is eth. Single bond between them, N. And due to this whole functional group, it is called amide. So it is ethane amide. Is it clear? This is just introduction of how you name these type of functional group. In detail, you will have a questions related to this part. Like these are some examples. The functional groups which is indicated by a prefix or a suffix, like example chloroethane is there. So when a suffix added in the following way, like if a suffix started with a vowel, what you will do? You will remove the e from the stem, like example alkane name is there. So prop n and one all. We remove butane. We did not write ane. We remove e and we write amine. Ethane. We did not write ane. We remove e and we wrote oic acid. Ethene. We did not write e. We remove e and write the name of the functional group, the suffix. And if the suffix start with a consonant, or there are two or more other functional group, like example di or tri, then what we do, we don't need to remove e. Like example propane, so we did not remove e and we wrote nitrile. Ethane 1,2-diol, propane dioic acid. So when same way, like example propane 1,2,3-triol. So if there are different number of functional groups are attached, in that case we do not remove e from the name of these uh, hydrocarbon and we write it complete. Then the position of the functional group on the carbon, how to identify. So whenever you position, like example, first thing you select the longest carbon chain. After selecting a longest carbon chain, the numbering should start from a nearest branch. So if I number from left hand side 1, 2, 3 and 4. So fourth carbon is having OH. If I number from right hand side, first carbon is having OH. So we should always give priority or count the carbon where the functional group is closer. So the position of the functional group on the carbon chain is given by a number. So counting from the end of one molecule, that gives the functional group the lowest number. But for aldehydes, carboxylic, nitriles, the functional group is always the first carbon, because like for carboxylic acid, it is C double bonded with O and OH. So that's the first carbon. All the things are attached. That's second, third, fourth, but this is always the first carbon. Same thing, aldehyde, C double bonded with O and H. All the others are the second, third, fourth, but this is always the first carbon. Same way, the nitrile group. So this is always the first carbon. And we only include numbers if they are needed to avoid. Like example, in this case, when we want to name this structure, so if you want to avoid ambiguity for this example, if I select the longest carbon chain and I number 1, 2 and 3. So what we have, second position, we have what is outside is a branch. So second position we have a branch. So 2-methyl, because 2 is the position of a branch, meth because there is one carbon, and YL because of it's a branch, and prop because there are 3 carbon atoms, that's why it is prop and single bond N. But this 2 will not make any difference. Why this 2 will not make any difference? Because when you have 3 carbons, so it is obvious that if carbon was attached to first one or carbon was attached to last one, it will not be a branch. So you are left, it's only one possibility is there, that the carbon can means the branch can be attached with a second. So in that case, we do not include the number. We can write this as methyl propane. Is it clear, this part? Then the functional group take the this means we give a priority to the functional group compared to that of branch. Like example, from this name, 3-methyl butadiene is correct, not 2-methyl butadiene. I will show the structure, like what's the meaning of this. So we have C double bonded with C. 4 carbon atoms are there, and then there is CH3 at the. Now, first thing, from one end to another, we select the longest carbon chain. So if we select the longest carbon chain, so this is our longest carbon chain. Then numbering should start from nearest. Now, if I number from here 1, 2, 3, 4, branch is coming at 2 and the functional group is coming at 3. But if I number from left hand side 1, 2, 3, 4. So here when I count, the functional group is coming at 1. So we always check, like when there's a branch and the functional group, so our numbering should be closer to the functional group. It's not about the branch. So we should always give priority to the functional group. So that's why we are following a numbering from left to right in this example. So we have a branch at 3rd position. So 1 carbon in the branch, it's methyl. 4 carbon, it is but. And because there is the double bond with the first carbon between first and second, so but it's one considered as 1, so it is but 1 ene. So it is 2-methyl but 1 ene. So we always give the priority to the functional group, not the branch, when we are counting. Then, for example, if there are 2 identical branch groups, functional groups are there, or 2 identical branches are there, then we use the word di. If 3 are there, tri. 4 are there, tetra. So in this example, we have 1, 2, 3, 4, 5 carbon. So we select the longest carbon chain, then we number. If I number from left hand side, 1, 2, 3, 4, 5. So 3rd and 4th position we have branch. But if I number from right hand side, 2nd and 3rd position we have a branch. So 2nd and 3rd position when we have a branch, so it's 2, 3, and 2 identical branches are there. So 2 branches di. What is the branch? If chlorine is there, we say chloro. Bromine is there, we call bromo, and if iodine is there, we call that as iodo. So it's bromo, and because there are 5 carbon atoms, so it is pent. They have a single bond between them. It is in. So it is 2,3 dibromo pentane. And when we want to separate, like example, words are separated by number with the dashes, and numbers are separated by each other with commas. You can see, like if it's 2, 2, like we have branch at second and third, so we separate them by a comma. But when we want to separate the number from the word, we use a dash. But if there are more than, like if two or more functional groups are there, then what we use, or two or more branches are there, then we use alphabetical order to name them. Like if we have, this is a structure. So CH2 with fluorine, and then CH2 is there, then CH is there with Br, and Br, CH2, and then CH3. So when we select the longest carbon chain, so this is the longest carbon chain, and we number the carbon atoms 1, 2, 3, 4, 5. So third position we have a bromine. If I number from right hand side, the first functional group is at third. But if I number from left hand side 1, so the functional group is at first carbon. So I will follow the numbering from left to right hand side. So it will be 1, 2, 3, 4, 5. Now how to name this? Because third position we have bromine and first position we have fluorine. So whenever we are naming the branches, or whenever we are naming the functional groups in prefixes, so we always follow alphabetical order. So it's not about which position, which one is attached first. It's about the alphabetical order. So in terms of alphabetical order, B is first. So that's why we have bromine. Third position, we have a bromine. So 3 bromo. First position, we have a fluorine. So 1 fluoro. And pent, because 5 carbon pent, and they have a single bond, it's N. So it's 3 bromo, 1 fluoro, pentane. Is it clear, this part? Naming the hydrocarbons and the functional groups till now. When we are naming the halogen alkanes, halogen alkane, like example, if fluorine is there, we'll use the term fluoro suffix. Chlorine is there, chloro, bromine is bromo, and iodine is iodo. The first rule is always select the longest carbon chain. So we select the longest carbon chain. The numbering should start from nearest functional group. So 1, 2, 3, 4. So second position, we have a bromine. That's why we call this as a 2 bromo and butane. For alcohols, if we are naming these alcohols, like if only a compound OH group is attached, so again we select the longest carbon chain. The numbering should start from nearest functional group. So here it's with the second. If I count from left and if I count from right, that's also second. That will be third. So I will count from left hand side. So second position we have OH. 4 carbon atoms are there, it's but. They have a single bond, that's why it is an. Due to this OH group, it is also, it is butan all. But the position of OH is also important, so it is at the second position, that's why it is butan 2 all. But if a compound is having both OH group of alcohol and carboxylic group, then what is the priority? The priority is carboxylic. The rule, the table for priority in the beginning, maybe you have checked this. This is a priority. So we give always priority first to carboxylic acid, then their derivatives, then nitrile, aldehyde, ketone, alcohol, and at the last, amine. So if we have carboxylic group and alcohol group, so our priority is alcohol group. So we will give priority, sorry, our priority is carboxylic group. So we'll give priority to the carboxylic group. So we select the longest chain, then we number 1, 2, and 3. So second position we have OH. If OH is considered as a branch, not a like functional main functional group, then we say it is hydroxy. The prefix will be, so 2 hydroxy. Second position we have OH, 2 hydroxy. Prop 3 carbon atoms prop, they have a single bond N, and due to this C double bonded with O and OH, it is oic acid. If 2 alcohols are there, then you will say diol, because you can see 1 and 2. So ethane 1, 2 diol. And if 3 are there, so propane 1, 2, 3 triol. For aldehydes C double bonded with O and H for aldehyde, and the name should always at al. And this is always the first carbon, so we don't have to number them. So we have 2 carbon, that's why it's at single bond N. And as we know that if a functional group, the suffix is starting with a vowel, so we remove E from N, that's why it is ethane al. In case of ketone, as you can see, 3, this is a symmetrical ketone, so we don't have to number them, that's why it is directly propanone. But this is not a symmetrical, and it is also contained 2 C double bonded with O groups. So 1, 2, 3, 4, 5 are there, that's why it is pent. They have a single bond ANE. Why ANE? Because when we are saying tri or di or tetra, then we use a complete ANE. And second position and second carbon and the fourth carbon have the functional group, so it's 2, 4 dione. And if you have C double bonded with O and OH with a ketone group, so when ketone groups are there as the first, like the prefix, so we use the term oxo. So you can see when we select 1, 2, 3, so it is 2-oxo-propanoic acid. And for carboxylic, C double bonded with O and OH. So this is propanoic acid. This is ethane dioic acid. Is it clear? Any doubt in this part?